very impressed with our spread that we had out. Hope you got to enjoy it. But if you don't know me, my name's Josh Wiener. I'm a first-year med student here at Case. And I just want to say, welcome to HyperCase's first ShowCase event. I am very, very excited to show you guys what we have to offer. Our teams have been working really, really hard to get these pitches together. They've already accomplished so much, and now is an opportunity for us to share exactly what we've been able to do so far. So to quickly introduce HyperCase as an organization, I'm going to ask our co-presidents, Elliot and Yvette, to come up and talk a little bit.
Hi, everyone. Not everybody can see me. Mike, that's better. Welcome to ShowCase. My name is Elliot. This is my co-president, Yvette. HyperCase started about in August when Yvette and I were at an MD Plus networking event, and she mentioned to me, why aren't people on campus across schools and different students collaborating? And I said, that's right, we should do something about it. And then 2 weeks later, we sat down and HyperCase was born. And throughout the fall semester, we worked to build a strong board for HyperCase composed of 12 very motivated, very ambitious, and hardworking students who are present here, who helped to build HyperCase and all its elements, the student interest, the student outreach, the student support, the faculty outreach, and the inter-institutional collaboration that we've been able to build so far. We opened officially in December. I checked the date recently. And in a span of a month and a half, we had 200 students, over 200 students interested from every single school across the university, from nursing to dental, to undergrads, to engineering, to medicine, to law, to business. Every single school had an interest. And within the span of 2 months, we have 4 teams who are present here today, and we're very excited. We're very proud of you. We're very excited to have you pitch today. 4 teams composed of students from every school, from law, from medicine, undergrads, engineering, business, who worked in an interdisciplinary manner, which is important to us at HyperCase, to develop and innovate within the healthcare space. That's something that's central to our mission, is the collaborative aspect of innovation, to mimic the working environment that anyone who's going to continue in innovation and in healthcare will be working in. Learning the vocabulary, the vernacular, the way of speaking, the way of working of other professions is essentially what we're trying to learn ourselves, but also teach here through experiential learning outside of the classroom, outside of the lecture hall, with our hands dirty, within a space that is without judgment, that is safe, where errors are allowed, where errors are invited. And so we had 4 teams working in the space of artificial intelligence, therapeutics, medical devices. Very proud to say that half of our teams made it to finalists of pitch competitions, and we were able to accumulate $5,000 in funding this round. This was a short round. This was 3.5 months, and we want to give a shout out to our participants who really put in the work by meeting every week and then pitching to us twice in our general meetings this semester. And today is going to be the culmination of their work. But then the road doesn't necessarily end here for them either.
Right, so today is the end of our first HyperCase round, but we hope that the journey of healthcare innovation doesn't end here, but rather we hope that your HyperCase experience will inspire you to continue to innovate in small or big ways, whether it be you joining a startup in the future, you starting a startup, or just building something that people want. So going forward, we're very excited to announce that we have started to build a national network of medical incubators across different medical schools. We're also very excited to announce that we are starting to build a network of alumni across different universities on campus. So we really hope to bring all the resources together to better support our participants, our past participants, throughout HyperCase and beyond. That's it.
Well, we are continuing in the next round. We're expanding the resources that we're providing to our participants. We're also expanding our structure. So this round, as you guys know, was 3.5 months. The next round is a full year. We're hoping to allow much more time for product development, for product optimization and testing, as well as a dedicated 2.5 months period for pitching, for supporting our participants to go to extramural pitch competition, to go and try to fundraise, to try to talk to angel investors, to try to pitch their proposal to our partner hospitals. Thankfully, we've started building collaborations with all 4 hospital systems in Cleveland, and we're hoping to flesh that out by the end of the summer. So the expansion of HyperCase is internal. It's also external. Through funding, through allowing our participants a better network of support by alumni, by faculty, and outside of Case Western as well. With that being said, we also have our team leader applications open in 2 weeks. So if anybody here is interested, keep an eye out for those emails. If you know someone who's interested in getting involved in the healthcare innovation space, reach out to us. Our email is hyper@case.edu. Keep an eye out for our website launching this summer, hyper-case.com. We tried to get hyper.case.edu. We couldn't make it. That would have been nice. And by the end of the summer round, our teams will be formed, and by September, our round will officially be launched.
Right, and before we get started, I want to introduce our amazing e-board. Let's start with our faculty relations branch, Sean Lee and Sonia Kim. And we have our executive management, Josh. Have our structure, development, and curriculum, Milan and Nafis. Finally, we have treasury, Pratik, Armand, and Parsha. And then we have recruitment and outreach, Tassim.
And Caitlin, who's not here.
And Kaylin, who's not here.
And with that being said, we'd like to introduce Sean, who is going to introduce our great panel of judges today.
I'm happy to see everyone here today. So for ShowCase, we have been able to bring in 4 incredible judges to help provide our teams with very valuable feedback, and we really appreciate their time. To provide brief introductions, we have Dr. Jenna Coxis, who is a first-year radiation oncologist resident at the Cleveland Clinic, and she also founded Drexel, which is the student incubator there. We have Mindy Barrell, who is the senior director at the Veal Institute, and who is also the CEO and founder of Saratoga Enterprises. We have Tiffany McNamara, who helps develop and lead partnerships with Sears ThinkBox as their senior director. And also we have Dr. Brian Rothstein, who is a pediatric neurosurgeon at UH Rainbow and Babies Hospital, as well as the chief medical officer at UH Ventures. Last but not least, we have our wonderful director of treasury, Pratik, who is also filling in as our 5th judge to help provide feedback to our team. Again, thank you, judges, for coming in and helping our teams progress with their projects and receive wonderful feedback. We really appreciate your time, and we look forward to seeing your questions and seeing the comments that you make for our teams. Thank you.
Again, thank you, judges, for coming to support us and helping us out. Sorry, Pratik, that your name was up there. I just did not. Your enthusiasm is. I didn't even know that you were judging, and that was great. But yeah, as you can kind of tell, it kind of takes a village to make this all work. So the executive board of HyperCase has done an incredible job, and it's been a pleasure to work with them. But just to give kind of a general overview of what today is going to look like, if you're not familiar with how pitches work, as Elliot said, we have 4 teams. Each team is going to have between 5 to 10 minutes to present their product. These are going to be, the presentations are going to include things like market need, market analysis, what their actual device or innovation is, sponsors, things of that nature. And there's going to be a 5 to 10 minute Q&A session afterwards. So if you have any questions or if there's anything that piques your interest, feel free to speak out. I will moderate the Q&A. So if you just have any questions, we don't have any microphones to hand out, so you will need to speak out a little bit. Sorry about that. But after that, we'll have a 5-minute section for judges to deliberate and work through their judging of our teams. And we will then have a little award ceremony for all of our teams. So, and then afterwards, we can go back to our wonderful spread outside and enjoy some more food. So with that being said, I would like to invite up Team A, Hemostat. Hemostat.
All right, thank you for the introduction, Josh. So as you heard, we are Team A, here to present to you on Hemosan, our product, which is an implantable and resorbable hemostat for use in postpartum hemorrhage. So there we go. Here's our agenda for today. We're going to talk to you a little bit about what postpartum hemorrhage means, why we're here to discuss it. We'll give you a little bit of background information on the current solutions that are already available for this condition, break down our needs statement for you, lead into a description of our product. We'll explain to you where we're at with intellectual property, and then we'll get into a little bit of analysis on the market drivers and the key stakeholders at play in this innovation, and of course, open it up for questions at the end. So to start here, there's a really big need to discuss maternal mortality, both in this country and nationwide. There are every year 14 million cases of postpartum hemorrhage, which is a dangerous and life-threatening complication after birth, where the person who has just given birth starts to bleed in an uncontrollable fashion, and this can quickly escalate to the point of death, as evidenced by the 70,000 global deaths that occur nationwide, a number that is staggering and also unacceptable in today's world of medical technology. Maternal mortality is also, postpartum hemorrhage is also the leading cause of maternal mortality, accounting for over 35% of all cases of pregnancy-related death. This is a really, really significant complication for people giving birth, and one that there is still a lot of work to do in research and development for management. So to talk about that current management for postpartum hemorrhage, here's a little bit of an overview of the solutions that are already in play and where the inadequacies fall. The first-line therapy in most settings of postpartum hemorrhage is oxytocin. And while this does work for a good number of people experiencing this type of bleeding, it is often ineffective in a large percentage of those who experience this complication. Additionally, it is not a very stable medication. It requires substantial refrigeration and other preservative techniques. And it also requires someone who's trained in giving an intravenous infusion in order to use this therapy, which really limits its application out of formal medical centers. Some additional second-line therapies when oxytocin fails include drugs called antifibrinolytics, which are another type of drug that's used to reduce bleeding, and then pressure-based hemostasis mechanisms. The antifibrinolytic drugs, while they are sometimes, again, effective, they also are extremely risky, carrying a lot of significant side effects, as well as a lot of really important drug-drug interactions. When you consider the proportion of people in this country who take medications related to blood thinning, clotting, perhaps aspirin, these are things that you don't want to have to be worrying about when you're making emergency medical decisions. Pressure-based hemostasis techniques are also invasive and require advanced training. For example, shown here in the photograph is considered a balloon method of providing pressure-based hemostasis. The balloon is designed to inflate to create pressure within the bleeding uterus. Again, this requires advanced training to be able to use the device correctly. It requires access to facilities that can provide this kind of invasive intervention. And it is also generally considered to be a quite painful and uncomfortable intervention for the person who's bleeding, adding a lot of stress to an already dangerous situation. The last resort in postpartum hemorrhage is surgical intervention, which is obviously a time-consuming and risky endeavor that carries a high rate of mortality as well as permanent infertility. Unfortunately, these surgical interventions can often progress to the point of needing to do a full hysterectomy or removal of the uterus and other reproductive organs. So as you can see, there is a lot of shortcomings when it comes to this treatment, and a lot of really significant side effects that we don't have a way to manage at this time. And that brings us into our need statement. What we see is a need for a way to control postpartum bleeding quickly, safely, with reduced pain, and the ability to apply this in non-medical settings outside of the hospital. There are a lot of people who deliver birth outside of these formal medical settings, and we need a way to bring the solution to them, not only in the setting of the hospital or other medical facility. So that brings me into our product. And while I don't have a visual for you of our product, as that is still something under the final stages of workup within our group, I'm here to describe to you what this type of product is and how we envision it proceeding forward, without getting too much into detail that might be sensitive intellectual property as well. The product that we're looking to design would be composed of a chitosan-based gel that would be administered intravaginally. So chitosan is a safe and reabsorbable natural polymer that is already used in a number of hemostatic bleeding controlling situations. Namely, the US military uses this in gauze and bandaging for skin surface level bleeding and has found a lot of efficacy with its hemostatic properties there. The reason that chitosan hasn't previously moved forward into other things like surgical settings, as I'll get to a little bit later in this presentation, has to do with the ability to render chitosan sterile. We are going to bring in a way to render this chitosan sterile for use in internal settings. And again, because this is a natural compound and it's something that is resorbable by the body, we already know this from previous applications of chitosan. This would be something that doesn't have to be removed later in a second procedure. It could be naturally broken down by the body. Where we come in with our innovation is the novel delivery system. Because chitosan is a natural polymer, it is not something that can be patented, but the delivery system by which we administer this gel in an intravaginal space is novel and is something that we're seeking to pursue as our intellectual property. We're proposing a novel delivery system that would allow for anyone, including people who are not trained medical professionals, to deliver this gel through a transvaginal approach to provide direct and immediate hemostasis in the setting of these life-threatening hemorrhages. In terms of the manufacturing side of things, we're looking to secure a licensing partnership with a company that is already producing similar products to take advantage of their supply chain that's already established and their national reach. For example, components of our device might include a lot of similarities to catheter tubing that's already used for things like urinary Foley catheters. So a licensing partnership with the corporations that already produce this technology will save a lot of unnecessary work in trying to reinvent something that's already working well. To build on more into the intellectual property, I mentioned that one thing we're bringing to the table is a way to deliver this chitosan compound in a sterile fashion beneath the surface of the skin. Our partners at Caramedica, which our faculty advisor unfortunately couldn't make it today, but he's our affiliate at Caramedica, they have developed and patented a novel technique for sterilizing chitosan that hasn't been done before. Traditional sterilization techniques render chitosan unstable or unable to perform its blood clotting properties. But the techniques developed by Caramedica have found a way to create a surgically sterile form of chitosan that still retains its hemostatic property. And that's what's allowing us to go into this novel device design now. To talk to you a little bit about our market analysis and our market drivers, the global postpartum hemorrhage market is currently actively growing and is expected to reach over $1.3 billion by the year 2030. Unfortunately, this is partially because maternal mortality rates due to hemorrhage are also increasing, and access to obstetrics care is becoming increasingly limited. Within the United States, we are actively observing a concentration of obstetrics and gynecological care in smaller and smaller areas of the country, increasing the size of areas within the country where there is not adequate access to obstetrics care, especially care that would require a hospital setting or a trained surgical provider. This really underscores the need for a technique to address this hemorrhage in a non-clinical setting, to address these needs where we have massive pockets of inadequate OB/GYN care within the country and beyond. Some stakeholders who really seek to benefit from our innovation, obviously, first and foremost, we want to center the patients who are impacted by this condition. Our proposal here would minimize the complications experienced from postpartum hemorrhage and enhance individual outcomes. We're providing a solution that would decrease the risk of pain, decrease the risk of permanently losing fertility, decrease the risk of death. And this is something of significant benefit to patients in a really common condition nationwide and globally. Providers also seek to benefit from having another option in their arsenal that is easy to implement and can overcome a lot of the shortcomings in the current options at their disposal. Healthcare organizations stand to benefit from saving time spent in the hospital. This is an intervention that could reduce the likelihood of costly hospital stays, and also some positive impacts could be seen in reimbursement rates as well. And then lastly, the payers into our system stand to benefit from massive healthcare-wide cost savings. As I've mentioned, our intervention is something that could reduce things like costly hospital stays, reduce things like surgical interventions that are known to be really cost-draining in the healthcare system, and provide a cheaper and effective alternative there. So our current timeline with our group right now, we are, as I mentioned before, finalizing those last details in our product design, as well as refining our formal pitch deck. And we'll be looking to then take this pitch and present it to OB-GYNs in the field to hear their feedback on what would be more or less beneficial to them in their practice and their thoughts on our current working design for our product. Once we've had these conversations with OB-GYNs, we'll look to make some edits based on their expert feedback and fine-tune our product before moving towards development. And at that point, we'll look to secure a more longitudinal OB-GYN partner to explore clinical investigation of the product and then eventually implementation in a clinical setting. So with that being said, we hope you're excited to help us tackle the problem of maternal mortality, and we'd be more than happy to take any of your questions.
Okay, that was great. Yeah, so if anybody has any questions, this is a great opportunity to ask.
Yeah, just to repeat into the microphone, the numbers that we quoted are the market within the United States. That global market of 1.3 billion would be larger in an international space. Yeah. So just to repeat the question, it was about the percent of people for whom oxytocin is ineffective. That is not a number that we have, and it's a little bit of a difficult number to pin down because effectiveness can be a bit of a sliding scale rather than a binary outcome between effective or not. The reason oxytocin is given is to mimic the natural burst of oxytocin that a person's body expresses after delivering. And the idea is to try to augment that response with oxytocin. So the extent to which it's effective is very dependent on the extent to which the person who has given birth is already producing oxytocin. And that is something that can vary significantly between people. So it is not something that we know as a hard and fast number, but it is something that we know is not necessarily accessible to everyone who is experiencing a hemorrhage. And so we would be looking to also capture a market where oxytocin can't be given whatsoever. Yeah, in the front row.
You don't have an idea what the cost is. Talk about the market. What I think about are the women that are moving out that are not of countries. Somebody doesn't pay for that. It's like a non-profit. So what are your thoughts around it?
Okay, so to repeat the question there, it was discussion about what the cost model and cost structure would be for this product, given that a lot of the people who will be most in need of this are A, in emergency settings, and B, maybe in less developed scenarios or with less access to structured care. That is something that is still a little bit of a work in progress for our group because our manufacturing pipeline is something that is not settled for us yet. But one thing that we do want to take advantage of is a lot of the similar products that are already in use, such as Foley catheters or BD's syringe barrels. These are already something that are marketed at a very low cost. Things like syringe barrels, for example, often are less than $1 per barrel, and that is at the consumer level, not the cost of production, which is even lower than that. So something that we hope to see is that the raw materials that go into this product design are inherently low-cost materials that would allow us to offer this at a lower price point while still being able to preserve a margin that way. Something else that we've taken into consideration on the topic of price pointing is The ability to incorporate our gel as something that is shelf stable over very long periods of time, which would allow our device to be something that does not need to be continually replaced or continually changed out over time. As something that could be kept by a clinic or by a person in their own home for extended periods of time to try to minimize costs that way. But I hear your question, and I agree with you that it will be something of high importance to us going forward to create a way to really minimize that cost to the recipient so that this doesn't become yet another tool that is only accessible to those who are more privileged.
And your partner that's sterilizing, are they, is it a partnership to standpoint of cost savings as well? I can imagine that would be a patented process. There's some cost associated with that. So is that a true partnership in that term too?
Yes, so we are in a true direct partnership with the Caramedica company, and the discussion with our advisor there is that while the intellectual property of the device design would be to remain within our group here as part of our HyperCase team, it would be an exclusive licensing agreement with the Caramedica company, where they would be the sole, they would have the sole right to use our design for the delivery. Yes, here.
What was your favorite part of being part of HyperCase? Part of the best work being part of it?
Yeah, that's a great question. To repeat the question, it was what our favorite part of being a part of HyperCase was. I'll let any of my team members come in first since I've answered a couple questions in a row if they want to start.
Hi, I'm Osvaldo Rodriguez, and I would just say that the experience of having an idea and actually working collaboratively with our team and getting this idea and having a lot of progress in such a short time, and just having the time to work with some amazing people. So I think basically the whole experience has been excellent.
I would just add the interdisciplinary aspect of this, coming from the law school and having a background in pharmacy. There's not very many opportunities within the law school that provide this type of environment. So.
And I think I just agree with everybody else that it was an incredible experience just to work with so many different people from so many different backgrounds. So it was an incredible experience.
Yeah, definitely have to echo my partners here that getting to work with people from different schools that I probably would have never run into otherwise has really been, I think, my favorite part so far. Being in the medical school, I don't often get to see people outside of my medical school class on a regular basis. This was a really wonderful opportunity for me to branch out that way too.
Question.
Yeah.
In terms of you guys discussed the number of cases with postpartum hemorrhage and number of deaths, are you guys able to extrapolate just epidemiologically which groups were affected by this or is there socioeconomic status? Is there demographic? And the second question I have as part of that is where are these deaths happening? Are people that dying at home? Or are they dying at the hospital? Does the hemorrhage happen at home? Does it happen at the hospital? I think that those are really important aspects of thinking about delivery and how you're thinking about your company.
Yeah, so the first question here was about the demographics that are most affected by postpartum hemorrhage. And while that wasn't a part of our presentation today, we have seen in the literature that postpartum hemorrhage, while it happens at somewhat consistent rates across different demographics, the negative outcomes associated with it are unfortunately clustered more heavily and disproportionately in historically underrepresented demographics and underprivileged groups. For example, non-white women are more likely to experience significant complications from postpartum hemorrhage and other things of that nature. We also see some clustering of outcomes based on geographic diversity within the United States, where some of the more significant negative outcomes are clustered in more rural areas, where there is limited access to care as well as limited ability to get to the care that is in those areas. And that leads me to answering your second question, which is about where these deaths and other negative complications are happening. And one thing that really influences the likelihood of these events happening is the amount of time that is required to get from the site where the bleeding occurred to a medical facility that can provide the current intervention options. When these hemorrhages set in, they have the potential to be extremely rapid, where significant complications and fatality can occur on the order of minutes, not hours. And if you imagine that if you have someone who lives 30 minutes away from your nearest hospital looking to pursue a home birth, there is no, we'll just get you to the hospital and work on it there. That's not enough time. So in terms of where these most serious outcomes are happening, they do happen everywhere. They happen in the most urban of centers too. They're more likely to happen in situations where people prefer to have home births or where people live a greater distance away from large hospitals that can provide things like surgical intervention. Although, of course, some of the other complications, such as loss of fertility, those are things that happen in the surgical setting. So those specific complications would be localized to where the surgeries are happening. But overall, negative outcomes tend to be seen in more rural and underserved areas that way. Yes.
And then is the skill level required to do this injection, is that something you thought about?
Yes, so the question is, what about the skill level required to perform this injection? And so we're looking to this to be a product that would require no formal medical training in order to be administered. One thing that we've considered as sort of an analog to our device that helps us feel comfortable that this is an attainable goal are at-home insemination kits, which is another type of device that allows for an intravaginal delivery and is done by untrained medical professionals in the home setting on a regular basis. Our device is obviously necessarily going to be structured a little bit differently from that type of product, but we do see it as being something that would require a similar level of understanding and skill, where in an ideal setting, yes, someone would walk you through how to do it, but the type of thing that requires no certification or training to be allowed to do it yourself.
So your OBGYN that you're going through the 9 months training.
Yes, exactly. It is something that we would love to see part of the prenatal care explanation that, you know, this might be a complication you never have to come across, but if you do, it's in your best interest to know how to use this product and to have it on hand. Yes.
All right. Yeah, we're at time. Thank you, everybody, for your questions. With that being said, thank you to Team A. That was fantastic. All right. Okay. Now I'd like to invite up Team B, the Regina Project.
Can everyone hear me? Okay. Good afternoon, everyone. Thank you for joining us today. It is our pleasure to introduce to you the Regina Project. This is a voice analytics-driven smart speaker poised to revolutionize delirium diagnosis and management, guided by Dr. Drummond and facilitated by the members of Team B. Let's start with some background. So what is delirium? Delirium is a dramatic but serious change in mental ability. This can present as confusion, drowsiness, and also aggression and irritability. This can result in behavior and cognition disturbances caused from illness, dehydration, infection, medication, drug use, surgery, etc. It is very common to see delirium in those in the ICU as well. You may be taking a lot of medications and your body is fighting really hard to heal, making it more likely to experience delirium. Let me also make it clear that this can happen to any age group, though the elderly population is a group that may be particularly susceptible. For example, as you get older, your mobility may decrease, and it becomes harder to constantly get up to go to the bathroom, especially with limited assistance. This leads to drinking less water, resulting in dehydration, which is another common cause of delirium. So therein lies our problem. The problem at hand is that due to the workload of providers combined with the potential of being understaffed, the nuances of detecting delirium can escape a busy provider's attention. Delirium affects 18 to 35% of patients in the acute hospital setting and can reach up to 70% in the long-term care setting. In the acute hospital setting, or the ICU, it can be difficult to continuously check the status of delirium when addressing the more critical needs of the patient as well. Those in long-term healthcare settings, however, such as nursing homes, are much more prone to developing delirium due to the lack of constant oversight. Furthermore, there currently lacks standardized, efficient tools to consistently measure and assess delirium in this long-term care setting. On top of that, roughly 70% of nursing homes are understaffed, and about 19% of hospitals are understaffed. This problem can cause $4 to $16 billion annually in the United States alone.
With regards to some of the issues at hand that are leading to the issues that we're seeing with regards to delirium diagnosis and management, it really comes down to two key factors that we saw needing to be addressed. Number one being that there are critical staffing shortages, as was discussed earlier. 1 in every 4 hospitals and up to 94% of nursing homes are reporting staffing shortages, especially after the COVID-19 pandemic. This leads to not only a decrease in personnel who would be at the bedside monitoring delirium, but also it leads to the personnel who are working being significantly overworked. And therein comes the second problem. In order to monitor delirium, given how common it is and how acute the onset can be, nuanced monitoring is required. The current method in current ICUs being used is called the CAM ICU detection method. What this is a bedside detection method that takes anywhere from 2 to 5 minutes to complete by an experienced professional. However, while this method exists and is up to 70% accurate, it isn't always implemented due to the fact that our staff are currently are significantly overwhelmed and overrun in hospitals and nursing homes. And so we find that up to 73% of patients are insufficiently monitored in care settings such as hospitals and nursing homes. Therefore, what we find there to be a need in is a way to improve early diagnosis and longitudinal monitoring of delirium in understaffed healthcare facilities.
And this leads us to a potential healthcare solution for delirium management, which we call Regina. And Regina will help us facilitate delirium management in critical care units. Regina is a machine learning driven smart speaker, which has the ability to monitor voice and speech patterns for delirium detection and diagnosis. So what we propose is a smart speaker kind of in the Amazon Alexa style, which has the ability to hear patients, analyze their voice patterns, and then detect delirium based on changes in their voice patterns. What we propose is to integrate natural language processing algorithms and daily conversational agents and combine them to respond to patient-specific voice pathology. We would like to create algorithms which have the ability to analyze normal patient voice patterns combined with their delirium voice patterns and compare these differences in order for the machine to cause alert and be able to diagnose delirium within our patients. We believe that this smart speaker solution has great value in our current market. First of all, because it will be able to monitor the progression of disease in patients throughout the use of the device in care facilities. As Anne mentioned, we would like to implement this device in both ICUs and nursing homes, as these are the places where patients are most at risk for developing delirium. As Tassine also mentioned, the current CAM ICU method for diagnosing delirium is very inefficient, as it requires a physical physician or nurse to communicate with the patient 2 to 5 times a day in 2 to 5 minute intervals every single day. And this, along with the current staffing shortage crisis, can allow for misdiagnosis and underdiagnosis of delirium. However, our product, on the other hand, will allow for 5-minute check-ins with the machine between patient and machine. And these check-ins can be initiated by a caretaker or on a timer on itself 2 to 4 times a day. After the patient checks in with the device, alerts will be sent to designated points of contact. This could be a physician, a hospital floor lead, etc. And the machine will be able to alert these points of contact if it detects that a patient is at risk for developing or is currently undergoing delirium. Additionally, this machine will allow for earlier and more efficient detection of delirium and will therefore allow our healthcare officials to implement preventative care for patients who are currently undergoing delirium.
So while the market is difficult to analyze given the burgeoning nature of this technology, we can extrapolate some of the data from the global health virtual assistant market in order to understand what the market for Regina may look like. The global health virtual assistant market will hit a predicted $3.5 billion in 2025 alone. Already, 19.1 million people are using voice assistants to aid in healthcare, and more than 50% of the general patient population have expressed an interest in doing so in the future. However, it is expected that this market for healthcare virtual assistants will actually be dominated by the providers in market forecasts from 2021 to 2028. Therefore, we anticipate that key consumers of this technology will include hospitals, care facilities such as nursing homes, and sufficient clinician and a wide variety of clinicians' offices as well.
So the current Virginia already has technology that's developed, and so it uses algorithms in AI, particularly deep learning. But the problem with this algorithm is that it's centered around a German database, and it uses natural language processing and acoustical analysis to detect delirium out of all the voice samples in this database. So the only drawback about this is that accents have a huge impact on the acoustical analysis of detecting delirium in voice samples. And because certain accents emphasize on certain frequencies, and those vary based on the diverse accents that is out there. And that's why we believe that there's not enough data available, not enough diverse data available to make a reliable program or reliable technology that can detect delirium in all sorts of voices.
So going off of what Treya said, how do we take it from the prototype that it is right now to a reliable clinical tool? Well, thus far, we have constructed a prototype with a natural language model, natural language processing model already having been created. However, we're in progress with regards to testing the machine learning model. We're developing 3 sample groups: healthy young controls, healthy senior, and ICU voice samples done in collaboration with a clinical care physician at the Cleveland Clinic, as well as performing a market analysis by analyzing the voice analytics landscape in healthcare and healthcare research.
So in terms of our goals and timeline for this semester and beyond, we had a minor short-term goal combined with a long-term goal. For the month of April of 2023, our goal was to create a protocol for voice sample collection with Dr. Bryson, and he is an ear, nose, and throat doctor specializing in voice at the Cleveland Clinic. More specifically, he's very interested in analyzing how voice pathology can be analyzed by artificial intelligence technology. So with Dr. Bryson's help, and as Cecile mentioned, we are currently in the process of creating 3 protocols for voice sample collections within clinical care settings. Our long-term goals for this semester and beyond is to create a literature review of the current software that is being used for voice pathology and understand the gaps in the market with this software. We want to understand the reliability and the risks of AI and voice recognition, the ethics surrounding it, and the current software that is in development also surrounding it. We also want to understand the financial and economic aspects of how AI and voice analytics can merge together and create a better solution overall. So in concordance with this, our next steps for after this semester are to write 3 protocols, which as Cecile mentioned include young control voice samples, elderly control voice samples, and ICU voice samples. We also would like to research and evaluate existing software to detect delirium through voice, which will be done through our literature review. And lastly, we will be visiting Cleveland Clinic's ICU to observe how delirium is currently detected in a clinical setting and use this information to better create a solution.
Okay, so what we've done so far is, like Ira said, conduct an extensive literature search, especially on both technological and non-technological fronts about how delirium occurs and what we can do to detect delirium through technology as well. And we've also started writing all 3 protocols. In fact, we've almost finished the healthy voice sample protocol, and we're waiting for IRB approval on it. Recently, we had a meeting with Dr. Drummond, who did talk to the IRB board and received feedback on what they would like to see at the protocol and what they would and the concerns that they would like to get addressed as a part of the protocol. So it's right now on the way of getting approved. We're now open for questions.
All right, what's up, Pratik?
Could you speak a little bit about your team and why you guys might be the right team to tackle this problem?
Of course. So why don't we all introduce ourselves? I'll start with my name's Tassine, and I'm a first-year medical student with an interest in not only, well, medicine, which includes psychiatry, ENT, all of which are tackled in this project, but also leveraging machine learning in order to help better streamline healthcare and actually using technology instead of like these super old-fashioned clunky giant computers and antiquated EHR systems.
I'll go next. I'm Ira, and I'm currently a freshman at Case Western, and I'm majoring in medical anthropology on the pre-med track. So obviously, I have a very clear interest in medicine, but I'm also greatly interested in creating people-first and emotional-based solutions for those who are undergoing medical issues. Because as Tassine mentioned, I feel like sometimes a lot of our healthcare innovations can be very science-first and technical first, and they don't really understand the emotions of those who are undergoing these medical issues in the first place.
I'm Shreya. I'm a freshman and I'm a computer science major pursuing the AI track. And yeah, so obviously I am interested in AI because it's the entire project or is largely based on it, along with an application base, which is something I enjoy. Interdisciplinary projects is something I really love working on. And yeah, so I'm really excited to be working on this project.
And my name is Anne. I'm a third-year computer science major, but I also did a few semesters of Case's nursing program, and I really enjoy both topics. Obviously, hindsight is 2020, and knowing what I know now, I found this club and combined both aspects of my interests, and this is something that really touches on everything and all the interdisciplinary characteristics that we all bring together. And I think though we are a very wide age range from freshman to medical student and varying interests, I think that this project really shows brings out the passion that each one of us has in kind of tackling this issue that we didn't necessarily know existed or we didn't know was such a huge problem. And I think it really brought to light how we can all come together to solve it.
We're also missing Basie, who's he's at the Weatherhead School of Management and is a graduate student in business, so also provided some of the business end. Ryan?
Yeah, so I was wondering if any of your literature research that you might, I know that there are some medical assessments where if the person is aware that you're doing the assessment, it can influence the accuracy of the assessment. Is that something that you need to be worried about because these are, the person talking to the device, they might speak differently than if they were talking to a person, or is that not something that is likely to affect the way they do it?
So generally speaking, that's a fantastic question, but generally speaking, the onset of delirium affects how one would respond even to how they know they're being observed. So there still are going to be discernible differences that will show up in the voice samples, which will be collected by the smart speaker.
To add on to what Tassine said, some of those differences could be slurring of words, speeding up or slowing down of words, and just general confusion and miscomprehension of words.
So my understanding of delirium is that it's more of a memory that is often an indicator of other questions and periods. So can you talk a little bit about why you decided to focus on delirium and how your solution would be able to adjust for the time span of delirium itself, whether it's day or what?
Yeah, so that's a fantastic question, and that's actually part of why we wanted to pursue this project, because unlike other, say, more chronic conditions, delirium is an acute one, and it tends to occur because of either neurodegenerative processes, aging, or medical issues that lead someone to be in an ICU. However, there are significant issues that are associated with delirium that need to be addressed when taking care of these patients, i.e., they often, as Anne mentioned earlier, they often tend either to have higher risks of, say, fall or physical trauma, while also having higher risks of dehydration and other issues that need to be monitored by care staff. And so acute monitoring in these settings is extremely important. And to lead into our answer to the second part of your question, the way we envision this smart speaker being used, and obviously I will emphasize that we are in talks with a group at the ICU in order to further develop how exactly it would fit best in their caretaking protocol. But given that CAM ICU needs to be done at least anywhere from 2, but ideally 4 or 5 times a day, we foresee the smart speaker being used anywhere from 2 to 4 times a day, either on check-ins that are initiated by a provider. So provider turns the smart speaker on, it does its check, takes about 5 minutes talking to the patient, or are set by a timer, so that way it knows anywhere from 2 to 4 intervals throughout the day to check in with the patient. And if at any of those check-ins, issues are noted that seem to be similar to a delirium sample, then an alert would be sent to whoever the designated point of contact is. Hopefully that answers both of your very thoughtful questions.
There's one more question.
All right, let's do.
I'm gonna say, so a lot of times in the hospital, delirium is caused by like sleep-wake cycles, beeping, actually more robots, like more technology. So I'm kind of afraid how's it gonna not cause delirium? Like the by itself by not having anything to do, but having another robot, another beeping thing kind of in the room.
Yeah, that's a great question and something that we're looking to consider as well. One thing of note is that this is intended, so unlike a lot of the other robots which have been noted to cause delirium, the things of note with regards to those is that one, they are not predictable, they occur at different times, and they also are jarring in nature. They're not meant to, one, sound comfortable or be conversational in nature. So while this one is robotic, it is a conversational agent. It is meant to, the way it, so one, it's going to be part of a patient's routine. So the patient will know it's similar to taking, like the way we foresee it being part of a hospital's care plan is while the patient is taking their pills, or if a provider is using the test while, say, changing drapes and whatnot, it'll be part of that. So the patient will know to predict it. And also it's going to be conversational in nature. There will be no like alarms or beeps from the device necessarily. It's going to be a voice that's meant to be more soothing and slow in nature, so as not to cause such issues.
Great job, guys. Thank you very much. Now it's my pleasure to invite up Team C, Redflix.
Hello, everyone. We're the team with Repwix at HyperCase. My name is Amy Budjakowski. I'm a first-year mechanical engineering student at the Case School of Engineering.
I'm Kevin. I'm a first-year biochemistry and finance student.
My name is Parsha. I'm a first-year medical student.
My name is Maya. I'm a first-year law student. And I'm Sonia. I'm also a first-year medical student.
So with that, we'll introduce Repflix. So I just want to begin the pitch by having everyone imagine a second grader named Liz. Liz was introduced to technology at really just key points in her childhood, starting from, let's say, YouTube videos to when her class went fully online because of COVID. Over time, she noticed that her vision was deteriorating, and even after going to the eye doctor, her glasses prescription did not seem to help. And over time, Liz was diagnosed with an eye disorder called amblyopia, and now she's predisposed to blindness for the rest of her life. Liz is just a really unfortunate representation of an increasingly growing number of children who have an earlier and increased dependence on technology and will also need vision-saving exams in order to save themselves from also lifelong blindness. And so that is why we are very excited to be here to introduce Repflix, which is a ophthalmologic exam tool that is designed to help with these vision-saving exams to help ophthalmologists get more accurate and also more speedy exams on young children. And so we've been working in collaboration with a pediatric ophthalmologist at University Hospitals, Dr. Rich Helms, to develop this device. And hopefully we're able to save millions of healthcare dollars in the future and also improve the quality of life for thousands. Okay, so a little bit of background about the pediatric ophthalmology space is that, as you can see by the numbers on this slide, Liz's case is not out of the ordinary. If I call your attention to other female children just like Liz, you'll see that there's an exponentially growing number of female children who need glasses or contact lenses as you progress through each age group, with almost 1 in 2 female children needing glasses or contact lenses by the age of 12 to 17. And all of these children represented here, including a similar pattern seen in males. This is only projected to increase exponentially in the future as well. And all of these children will need an accurate, they'll need to go to their ophthalmologist and get something called a refractive error measurement in order to get an accurate glasses or contact lens prescription. Unfortunately, if the pediatric eye examination is not done accurately, then it is the leading cause of childhood blindness, because an inaccurate refractive error measurement is associated with vision losing disorders such as amblyopia, which is what Liz had.
So we decided to perform a root cause analysis on the problem of getting inaccurate eye measurements. We decided this was due to 2 main issues, which is limited patient capacity and the inability of ophthalmologists to cope with this. When we say limited patient capacity, we really mean 2 things. 1, the inability to provide verbal feedback. Young children and those with disabilities do not have the ability to talk about their eyes. They can't tell us what's wrong. So we need an objective measure. And there's also a lack of focus on the bright light. Trying to get an energetic kid to just sit still is already an uphill battle. So getting them to sit still and stare perfectly into a bright, painful light is a whole nother story. So that's why optometrists need a way to distract the patient and get their mind off the bright light and off the exam room, while still getting a very clear view of the retina, which brings us to our needs statement.
So as we have discussed, young or disabled patients may have difficulty responding during eye exams. Their providers use the refractive error technique called the loose lens retinoscope. It doesn't require patient feedback. However, as Kevin said, it can be very frustrating for both providers and patients. That is why we present Retflix, which is an attachment that provides a distracting stimulus for patients to focus on, while allowing an unobstructed view of the patient's retina for providers.
Yeah, so this is an example of the Retflix device, which Rich Helms has been producing and selling on Etsy. The way it works is the provider or the patient's parent can place their cell phone device in the tray. And as you in the audience can see, it will reflect the view on the screen and to the patient and give the doctor a clear view through the hole in the mirror. This allows the parent to put on, the child's favorite TV show, YouTube video, distracting them during the exam and incentivizing them to sit still. This makes the exam easier to do for providers and provides more accurate refractive error measurement than they would be able to get if they're having to try and keep the patient from moving around while they take this measurement.
So as for market sizing, there are about 1,056 pediatric ophthalmologists in the United States. 95% of those pediatric ophthalmologists use the Welch Allen, which is what the Retflix was designed to attach to. So that's about 1,003 pediatric ophthalmologists who would purchase the Retflix. Now, 3/4 of those pediatric ophthalmologists is about the number we've estimated due to who's in a rural area who has access to Wi-Fi. And we've done some testing asking ophthalmologists if they would use this device, and it's been a resounding yes so far. So our analysis seems to be pretty accurate.
Yeah, so let's take a look at Retflix by the numbers. So as Maya mentioned, we conducted a survey of current users of Retflix to see, on average, how many devices would they purchase, what's the appropriate price for Retflix, and just to take a look at, our total market share. And based on our survey data, we saw that the average consumer would buy approximately 3 Retflixes, and most people are willing to pay a price of $60. So taking a look at our market, taking a look at the number of Retflixes each pediatric ophthalmologist would buy, and also the price point at which we would sell it at. We look at our revenue potential to be around $696,000. So in regards to future directions, one of the big things that we want to do is continuously improve our product. If you like to.
So we have a couple of ways that this could be improved. As we mentioned, we have sold a few Repflexes to providers and asked for their feedback on the device. And there are two primary areas that we're seeking to improve. The first is in the size of the device. We're seeking to reduce the bulk to make it easier for providers to carry around. We plan to try and add a hinge with a sort of ratcheting mechanism so that it still goes to that same angle every time. Additionally, we are looking into making this a modular design so that the head which attaches to the retinoscope can come off and back on. Again, just to make it smaller, easier to carry around. The other primary concern is ergonomics. Several providers said that they could only use it for a few exams a day because having the weight of the cell phone resting on the retinoscope put a strain on their wrist. So we're looking into ergonomic improvements to reduce that strain on providers and improve the experience.
Yeah, and part of continuous improvement is also taking continuous consumer feedback. So after making some of these changes, we would like to reintroduce a more developed product to pediatric ophthalmologists and see what they have to say in regards to the improvements in other areas in which we can improve Repflex. And also another important aspect of this product is the marketing of it, making sure that people are aware that this product exists and the benefits of, this product in regards to keeping a small child's attention when taking eye exams. And another long-term, solution we're thinking about in regards to continuously generating revenue is to potentially introduce a leasing program, especially because Repflex has a relatively long shelf life. We're looking at ways in which we can, have continuous revenue coming in. And one of the methods that we have been considering is introducing a leasing program where ophthalmologists would have the Repflex for a certain amount of time, and then once that time is expired, we would replace it with the newer Repflex. So these are just some of the avenues we've been taking a look at in regards to developing Repflex further. So yeah, that concludes our presentation, and take any questions that you guys have. Thank you.
You discussed all potentially using this open source opportunity. Where did you prototype that?
I'm going to say, so this is not actually our prototype. This is Dr. Helms. This was 3D printed in his home, and the mirror was laser cut.
Did you talk about that? Because the market is huge. What's the what are you making on those? So you said $60 is what?
These cost a couple cents to produce, maybe $1 max.
Yeah, it's around
so
$1.
It's got a pretty significant profit margin.
Okay. So yeah, you thought about doing it open source.
We haven't discussed it much, but I think that would be an excellent idea to bring up with Dr. Helms, who we've been collaborating with.
And we've also been working on getting a patent for this product as well. So I think that open sourcing it might, like if you're trying to get a patent and trying to open source, it might be in conflict to a certain extent. But that is something to consider for sure. Yeah, so we have considered adjustable heads. One of the nice things is with the Welch Allen, 95% of pediatric ophthalmologists use the Welch Allen, so it does cater to like a majority of the market. But we have considered on individual basis if someone uses ophthalmoscope that it has different dimensions, it is quite easy for us to customize those dimensions and 3D print it accordingly. So we've considered it more on a case-by-case basis rather than on a mass market scale, just because of the widespread prevalence of ophthalmologists using the Welch Allens. But it would be something that we would like to consider on a case-by-case.
Essentially increase your total addressable market. Take that into consideration.
It very well could. We focused on pediatric ophthalmologists for our market analysis because unfortunately at least we were not able to easily find much data on ophthalmologists specifically aimed at adults with disabilities, but that definitely could increase the market share. That was part of the original idea behind creating the device, was to also help with adults with developmental disabilities or inability to communicate. So the market could definitely be larger than what we've predicted.
Follow-up question that from that perspective, if you are going down the path of trying to patent the device, have you considered the discussion with well challenge from other device manufacturers who license the design, meaning that they could then build it into, I think you are refining your product, right? You're basically order and how much effective. Would you be open to or consider licensing that design to other manufacturers? They can build it, they can sell a product that way.
Yeah, definitely. That is kind of like the main purpose by which we're trying to patent the product, so that way we can approach companies and try to get this thing licensed. We have also identified a lot of specifically 2 different companies that specialize in pediatric ophthalmoscope attachments as well. So along with the manufacturer, maybe those companies might be worth considering for licensing opportunities as well.
I have 2 questions. One is, do you have data to show that in using it, there's a more accurate diagnosis? Because I could see kids already equally hyper if they're watching your show, or rapid eye movement that might be distracting, from the outcome. And the second question I have is not just is it the efficacy of it, but the time, right, of it. So by the time you have the person put their phone in, load up the program, know that there's bandwidth, the kid's watching, sterilizing before you get this, the white comes down. Does that take more time or less time than the amputee you're trying to get the bright light? Because they're going to be paid by turn, right? And the patient I'm seeing.
Yeah, so we definitely have a lot of qualitative data because of the survey that we sent out to current ophthalmologists using the Reflex. However, that is something that we look to do in our future directions in regards to quantitative data and making it more of a controlled study where we have a control group of patients not using the Reflex versus patients where the Reflex is used, and looking at what specific advantages the Reflex provides. So that is something that we want to do moving forward, is to have more of that quantitative data in regards to how effective the Reflex is.
One more question.
All right.
Cool. Thank you.
Okay, thank you guys very much. That was great. Now I'd like to invite up Team D, VoxCore.
All right, hello everyone. My name is Milan Patel. I'm a first-year medical student here at Case.
I'm Andrew E. I'm a first-year computer science math major.
I'm Matthew Glaros. I'm first-year part-time MBA student at Weatherhead with an emphasis in healthcare innovation.
And together we are VoxCore. And before I tell you about how our team aims to help patients suffering from heart failure, I'm going to let Matt tell a quick personal story about our team's motivation.
I had a story to share about a personal friend of mine, Don Marks, who I knew from church here locally. Dawn was struggling with congestive heart failure, and she had a relapse this past January with it, had to go back to the emergency department and receive intensive care for it. I was able to be at her bedside as she was dying at only 52 years of age. We just felt so powerless to save Dawn from this. And I made a commitment at the time that I was going to try to find a way to bring hope to those facing congestive heart failure and improve their situation. So following her passing, I jumped at this opportunity to help form VoxCore here and to do something about it. Since then, Don has become our inspiration for our mission to defeat heart failure. So Don is one of 6.2 million Americans who are facing heart failure, as you see on the slide here. There's a striking mortality rate of 13%. It's also very expensive, costing hospitals $31 billion annually. There's an alarming statistic as well that 20% of patients who are treated for heart failure will return to the hospital in less than 30 days. Part of this is due to the nature of heart failure, that it's difficult to detect because the symptoms mask themselves at times. All of this catastrophic loss and expense persists despite the availability of both treatments and knowledge about this disease. Our innovative VoxCore solution seeks to address and help overcome these pain points.
Thank you, Matt. So us here at VoxCore identified this problem and recognized that there's a huge opportunity and a huge need for a solution. So we sought out to develop a solution that would allow for earlier diagnosis of heart failure, combined with at-home disease monitoring to detect the changes of symptoms over time, with the ultimate goal of reducing hospitalization, saving costs, and most importantly, saving lives. We realized that this all can be accomplished using simple voice recordings from patients combined with the power of machine learning and natural language processing in order to figure out all this information from the patients and get it directly to doctors as soon as possible.
And I'll address the market. The market for a solution is huge and fast growing. The artificial intelligence healthcare and diagnostic global market is valued at $14.6 billion, with an almost unheard of compound annual growth rate of 47.6%. The main way we're going to capture this market is to appeal directly to hospitals as our buyer, since they are bearing the high cost burden for heart failure today. This is the main pain point we'll address. With buy-in and directives from hospital administrators, this will be the fastest way to engage as many users as possible, we feel, providers and patients. Providers, including primary care physicians and cardiologists, will be able to recruit patients diagnosed with at increased risk for developing heart failure in order to provide better care and improve long-term health outcomes. Patients as well will benefit with better prognosis, quality of life, and health outcomes, as my friend Don and other patients are seeking.
So our solution helps doctors monitor at-risk and diagnosed heart failure patients by having them download our VoxCore app. Each day, patients are prompted to provide voice recordings by reading simple sentences in their preferred language. The sample will be fed into a machine learning algorithm that compares the audio against their past recordings and a baseline healthy model. If a worsening condition is detected, our system notifies the healthcare provider through a streamlined connection with their EHR system. The provider will then be able to make appropriate adjustments to the patient's treatment and stabilize their condition. This helps avoid unnecessary hospital visits or episodes of acute decompensation. So taking a look at current methods, the current methods of heart failure detection fail to deliver on three major fronts: effective monitoring, early diagnosis, and use case. VoxCore's seamless integration of these three needs through our innovative design addresses all underlying issues and delivers the optimal solution for patients.
So here we have the lovely faces of our team members. We span across multiple Case Western schools, including medicine, engineering, and business. Together, we boast an impressive collective resume that includes research, innovation, and our overall strong passion for this project. We're guided by experts in the field, including biomedical engineering professor, Dr. Colin Drummond, as well as our entrepreneurial and industry mentor, Justin Vellante. And together, we feel that we're uniquely qualified to find a solution to this pressing need. Our time here at HyperCase has been very, very productive, and we couldn't thank them enough for their support. We started from a very broad research topic and was able to synthesize that into an actionable need. From there, we took that problem and need and developed a business around it in order to figure out how best to address this problem and get a solution to our stakeholders as soon as possible. And from there, we're starting our innovative solution development using the key principles we learned through this program and continually applying and iterating to ultimately make the best product possible. And that has brought VoxScore to what it is today. So our next steps moving forward, our first and primary goal is to develop our minimum viable product. We believe that we can get this done with an initial investment of $15,000 in order to fund the IRB approval for speech data sets and data collection, as well as getting some funding for software development and AI engineering. After we develop our minimum viable product, we'll seek clinical validation in order to run some pilot studies to get some stakeholder feedback on how the solution operates and what can be improved, as well as applying for FDA certification in order to prove and cement the efficacy of our solution. And lastly, we'd like to protect our intellectual property through a thorough patent review and applying for a design patent on our device. We hope that you join us on our journey to save thousands, if not millions of lives, including patients like Dawn, like we mentioned earlier. And we thank you for your time and attention during this presentation, the pitch day in general. Are there any questions?
I'm just curious, is there any good published data that changes in tone of voice is accurate in predicting change in health state?
Yes. So specifically, the reason why we chose heart failure in particular is because the primary and telltale symptom that doctors use to diagnose heart failure is putting a stethoscope to their chest and hearing this crackling sound in their lungs. And there's been data that's gone into the ability to assess this crackling, the shortness of breath, other respiratory disorders in the patient's voice that's able to be detected. And we believe that through the literature that we've read up on and our understanding of the disease state, that this is definitely possible. And there's definitely been a lot of research that's been going into it and proving that this is a very viable solution. That's definitely like a great question, and we definitely need to iterate through the different ways we can have the speech recording system set up. We are currently focused on making an app, as that's probably the easiest thing for patients to acquire. It doesn't require going out and getting a completely new piece of hardware. A phone is something that most patients use every single day, so that we believe that would improve the accessibility and reach of our solution. But definitely there is worthwhile consideration to other ways to record patient voice. You have to think.
You mentioned like 50% growth in the market size. Is that nationally?
I believe that's the global market predictions, right? So,
You want to pull that slide up?
yeah.
So here we have the.
That's not your.
No, this is the overall AI
So
diagnostic market.
The US market is 11 billion, and then the market we would target would be the 1.5 billion, 6 million patients dealing with congestive heart failure. Plus, there's those who are have conditions for like diabetes and things that they might want to monitor it for. We were looking at $250 per device, so that may be a little bit lower. We haven't quite exactly specified the pricing on that, but it is a large market. And with AI diagnostics, it is a very fast-growing market.
Follow-up question to that. Do you see the amount of people with congestive heart failure growing or staying stagnant or reducing the rate of smoking that's associated with developing cognitive benefits like those?
It's actually a growing disease because of the aging population. Patients are living longer. The baby boomer generation's entering that age right now, and so there are more and more diagnoses of heart failure and chronic conditions related to the heart.
The literature also showing that the recurrence of it is getting worse. Even though we're spending more money in healthcare in this area, it's getting worse. So this would help in all those areas.
Elliot?
What other medical conditions could cause like?
So this This technology can definitely be applied for a lot of conditions. You heard from the Regina project that was taking a very using a similar principle of analyzing voice and detecting delirium and neurodegenerative disorders. You can probably use the our ideas and extrapolate to any condition that causes shortness of breath or fluid buildup in the lungs. But what we really wanted to focus on, we want to focus on a specific need so we can make sure that we're addressing it one patient population as as effective as possible before branching out into other disease states. But we can definitely imagine a technology similar to ours being continually updated over the years, having more and more diseases on the profile of it being able to help diagnose. Yeah.
13%, you can be a little more information on it. Is that the first, so the mortality rate of 13%, is that the primary reason they died?
Yes.
And would they pass the natural life expectancy? Do you know?
I do not know if that percentage takes into account the natural life expectancy. That number came from the Center of Disease Control, just general epidemiology statistics on heart failure. Yeah, so that is definitely something we can definitely look into.
I agree that this is the perfect patient population to target early. My experience of this patient population is like we have nurses calling these patients when they get discharged from the hospital, trying to see if they rebound or if they get worse or better. I'm not sure that's ever led to change in outcome. Like, have you ever read any data about when nurses call these patients week by week that changes outcomes? So I'm just wondering, how is this going to change outcomes?
Yeah, that's a great question, and I think that more research needs to be put into that. And hopefully, once we have a prototype, we can figure out if it's able to change outcomes. But from what we researched so far, it's when patients are detecting their own deterioration due to heart failure, whether that's on the initial side of things, when they have not had diagnosis before, or if they've been discharged and are about to come back, the symptoms they're presenting with are all happening after the first detectable signs are happening. Like the pulmonary edema is what's happening first and could be detected first, but that's not what's going to lead to the patient's overall sense of deterioration. So the hope is that early detection will help promote better outcomes in the end.
You should also think about compliance. A lot of these patients are not compliant, so they're not going to want to ever.
Yeah, it's definitely going to be a yeah.
But talk to anybody about the because one, they may or not believe that there is outcomes, and two, they get to do it every day. They're not every day because their diet is good. Yeah. They're not doing those things either often. And then the idea too of counter stress is a daily reminder of actually just the heart failure and the outcome didn't fail.
Yeah.
So how often do I want to be reminded of that versus my life? Forget it. In that size of your market, where actually it's small space.
Definitely, we definitely want to talk to more patients, more physicians to learn more about that. But to speak on the taxing idea of daily monitoring, a lot of these patients are actually already undergoing daily monitoring. They're taking their blood pressures every day. They're weighing themselves every day to detect fluid buildup. So we felt that we can easily slip this right into their daily routine. Obviously, we don't want it to be too much of an addition to their everything that they're expected to do, taking medications, taking blood pressure, weight, definitely important considerations. But we hope that for a majority of these patients that they're already engaging in daily monitoring of their disease, and we can add that to the regimen, or if it's proven to be effective enough, replace aspects of their regimen. And by using voice, and there's a consideration, while this is not our primary objective right now, because we believe that it might cause more problems than good, if it's a passive monitoring system that doesn't require them to physically open an app or physically think about it, if it's able to detect voice passively, that could be a consideration to help those subset patients that might be non-adherent.
So as we engineer it as a software, as a medical device, we could look at some of those options and maybe give them the option where it could just continuously passively monitor them for those who wanted that, and it would allow it.
Take one more question.
how, like, that happened, because I feel like there's some amount of overlap between population. And that's, I think, the first thing that I think of, like your actual other device.
Yeah, definitely. That's the main reason why we don't want to commit to saying that we're doing passive monitoring. What the primary delivery of our device, what we want it to be, is voluntary use of our device in a regular fashion. And if we were to go down that route, it would have to be one of those considerations where we do research and can definitively say that the patients that are not adherent will respond to this design feature. But when in the case that would, like the likely case that it's not, we have to be innovative and come up with a better design feature that will address that patient population.
I'm also like hesitant to call it passive voice monitoring. I like to think of it more as active voice monitoring. These samples are voluntary. They are 1 to 2 minutes a day, where the patient physically presses a button on the phone to record their voice. I don't really think it's the same as like having an Alexa in your house at all times. The app does not record audio at all times.
Thank you so much for everyone's questions.
Great job, guys. Thank you very much. Okay, so now we are going to take a short 5 to 10 minute break. And that after all of our fantastic teams have gone, I think everybody deserves another round of applause for all our amazing teams. Great pitches. So we're just going to take 5 to 10 minutes to allow the judges time to reconvene and deliberate a little bit, and then we're going to come back and do our awards. So take this opportunity, grab some pizza, get a drink, and see you back in a couple minutes.
They can have more than one. So one improvement.
Really, really. So they got it in, you know. I mean, you're talking. I think it's gonna take you picture the product is not gonna hurt fertility. You're doing it for yourself. Right? And then just get clinical trial approval, like it's like, but in prison, pregnant people and children are like the hardest people to see and kind of study them. I think it's a great idea.
Yeah, I think it's great. Something sort of. Very different. Like spices or the real question, like, yeah.
That's what I feel like it's fun. Your husband is gonna really do it.
I don't think they're ever. I don't think that really ever was proven like. Well, this would be like, yeah, right, EMS. Basically, just trying to get. I'm sure they do.
Yeah.
But, And there are. There are other topics. And if there's a really high the new sterilization for a non-approved product like so I'm gonna make it.
After you have delirium, what do you do about it? Like, whether you even diagnose that or both. There's no cure for delirium.
What is that?
The delirium. Really I thought they were meant to part of it, but then I understand where it could be a lot of but again, there are a lot of I would say that you know,
Yeah, I think it's pretty super cool. I think it's, we use it in oncology, like that same idea in oncology a lot, like for radiation oncology, so you have kids who are trying to stay still in treatment and you just impact your body like off the screen. So I think the idea is super cool, but from a non-business perspective, like you are we're talking about so that
they need to provide bigger making are there other issues? It's, that happens like really a lot, right? There's a lot of talking about. I mean, the answer is, I think that, yeah, that was a great question, is who's. You're talking about durable equipment. For device, just swap it out, so whatever. Exactly right.
Yeah.
You never really have it.
And I wonder, I was.
Yeah. Their first presentation, not an insignificant.
Right.
Yeah.
I guess that.
Oh, they were great.
Yeah.
Yeah, excellent.
Yeah. Yeah.
And I would say there's that was my thought, they actually sold this.
Okay, one question. So tell me how that about their role. So it's not about the product.
Kind of nuances. Massaging. All right. Okay, that's fine. Yeah. And then. So you gave us that.
Okay, thank you everybody for your patience. Hope you guys got a little bit more food. We are going to start our award ceremony, and that will be hosted by our lovely co-presidents, Yvette and Elliot.
Very productive conversation with our amazing judges. We have decided on 4 awards for 4 teams. So I think each team has different strengths, and we really want to try to highlight those strengths by each team. So we have the first award, the Social Impact Award, is given to Team A.
The second award is the Market Leadership Award. The award is designed to give it to a team that has identified and has worked on a marketability aspect of their project. Whether big and small, we want to especially highlight and compliment the business aspect of the team. This team worked a lot over a few obstacles in a very collaborative way, very creative way. And we want to deliver the Market Leadership Award to HyperCase B. All right, so the third award is simply put the Best Pitch Award. I will, however, mention that every pitch today was complimented by our judges, and we'll note that it's obvious that each one of the teams today practiced, listen to the feedback that the board gave you during and after a general meeting. All of the pitches were excellent. However, the beneficial award does go to HyperCase, Team C. Coming up.
support is given to the team that is the most collaborative across different disciplines, from law, business, to medicine. And this award is given to, last but not least, our team E.
One member came in, another medical student.
Okay, so that concludes our showcase event. Thank you guys so much for coming out and spending a little bit of time with us. If you're not a current member, our interest form is linked here in this QR code. So please enjoy a little bit more food, hang out, and thank you again so much for coming and spending some time with us.
Yeah. But you can come up and get them at your leisure. So thank you so much, everybody, for coming.